All right, I think we are ready to start again. So Bob is now back with us and will present some recent work of his on principal agent models with asymmetric information. And so this sort of connects well with sort of the last empirical application that Horacio was talking about, namely the role of asymmetric information. So, yeah, thank you, Bob.
Thanks, Dennis. Yeah, we're moving to the other end of the wealth spectrum. And into the people who will probably end up moving. The reason for that is that when you're talking about managers, well, you're really talking about people who we get to see what they actually earn and also why they earn it. So when you're typical labour supply situation, you see the wages, but you don't really see the marginal product. Here you see something about the contract itself. Of course, that raises the question as to why there isn't even a contract to begin with, because in the narrative real world, where there are complete markets, and that's essentially the scenario that the ratio we're talking about break. Whether people are paid the marginal product, expected marginal product, doesn't really matter, because you can always insure yourself against these kinds of external contingencies. So when does the contract form matter? Naturally arises in situations where there is asymmetric information. And in what I'm going to do in the other watch is go through a very simple model where there's a risk principal and proposes an agent that is risk averse. And there's going to be a moral hazard model, hidden actions. So the principal will see whether the agent, of course, takes the job or not, but won't see what the agent does. The agent's going to have just a couple of choices, whether they're going to work or shirk. And here, those are just names for the agent doing what the principal wants him to do versus the agent doing what he or she would do if they were paid a flat wage. So that's what shirking means in this context. The revenue is realized, agent should get some compensation, and the principal pockets the remainder as profit. Now, I'll go through this simple model, and then I want to show how it's identified. I'll give you some estimation results that we've got, and these are fairly old, actually, wow. So what? And then I want to extend, and will extend, at least briefly, the model to a dynamic and framework, and then we'll go, and I'll go through that, at least to some extent. So here's the setup, because I really can't see how we can do the dynamic stuff until we've got the basics under our belt. So here we go. The indicator L is you either going to take the offer for the agent or not. And then there's going to be an effort choice as well. Okay, so you take the offer or not, and then you decide your effort choice. Revenue, the principal, is denoted by X, and you should think about this as returns to the firm. And the gross returns. And then when these gross returns are kind of revealed, that's going to be profits in this case. Some of it's going to go to the agent, some of it's going to go to and the rest is going to go to the principal. And that is the nature of this. There we go. Get that? A little bit. You can see profits minus this contract. That's the WX is the contract. Okay, you'll follow very simple setup. So let's imagine that the agent does what the principal wants him to do. And if that's the case, you get a density, probability density function that determines what we'll call the output or the gross revenue, if you like. And then on the other side, if the agent does what he wants to do, that is what he would do if he was paid a fixed wage regardless, then he's going to get this much. And here what I've done really is just for notational purposes, rather than write down another probability density function. What I've done is taken the original probability density function for working and then just hit it with a likelihood ratio. So it's the same thing, all right? So that's what happens if he shirks. And of course, the principal wants the agent to work. So the expected value, principal, remember, is risk neutral, gets this much out. Oops, gets this much out if the agent works. Okay. Whereas if the agent shirks, doesn't get as much out in expected profits, only gets this much out. So if we're talking about this E sign, what we really mean is taking the expectation when we're thinking about integrating over F. Okay. That's how I've done the notation. So this, as I said, is the likelihood ratio. Obviously integrates to 1. We've got an agent who is an expected utility maximizer. And I want you to notice here that the agent has exponential utility. Now, the reason I've done that is because I'm essentially removing much of the role of wealth when we're talking about risk sharing. Okay? So constant absolute risk aversion. The reason why you would do that in this kind of context is because you don't know very much about the manager's outside wealth. Inside wealth, yes, you can see what they're getting from the firm, financial securities, and all the rest of it. But what else do they own that you don't know about? Because that would affect their attitude towards risk, of course, if they didn't have exponential utility. And so you could potentially handle that in a theoretical way, no problem. But then you'd have to be integrating it out. So I'm not trying to justify this assumption on the basis of realism or anything else. The exponential utility assumption is being made here for attractability reasons. Okay? This is a little warning out there. So, okay, we normalize utility of something, and we're going to normalize it at the what they would get from their outside job. Now, mind you, in terms of management, if you look at what goes on with these people in C-suites, they're in the C-suite for a while, and then they're out. And the most common position for them to move after they're in the C-suite is out of it altogether. Okay? It's like equivalent of retiring. And people have these ideas that, you know, you just circulate from one top job to another. That's not really what goes on. The people who get appointed as CEOs tend to be CEOs from coming up through the firm. And so those guys survive a little bit longer. It's fairly unusual for CEOs to go from one firm to be a CEO of another firm. Usually they're out for a good reason. And that sort of excludes them later on. So, okay, this is their outside option, which is probably retirement, but it could be sort of consulting or something like that. And then this is what they're going to get if they work. And you can see that expectation just has the utility in there. And then over here, they're getting an expectation if they shirk. Now, there's this alpha parameter that reflects, it's really a consumption equivalent because, you know, you could always put a log and plug it in up here if you wanted to. Fair enough. And there's also a beta parameter here, same thing, you could take exponential of log and put it up there. So it clearly has a consumption equivalent, right? And notice exponential utility is always negative. That's the way it's defined, so it'll be concave increasing. And the alpha parameter is going to drag you down more than the beta parameter because you would rather shirk than work. And that, of course, is where the conflict arises in the first place, because on the one hand, the agent would like to shirk, so beta is pulling you up closer to 0, but the principal prefer the agent to work. Okay, so that's the nature of the conflict, and that's where the contract is going to arise. So how do we get that? How do we get the agent to work? Well, first of all, we got to get them. We got to hire them. Okay. And so it better be the case that the utility that you get from hiring them, even if they shirk, is less than or equal to, well, more than or equal, absolute value less than or equal to. Let's just go back to this one. Remember, everything's negative. So I got to worry about this thing being smaller in absolute value than this thing. All right. So that's where that one is coming from. It's call it a participation constraint. Remember, they have negative utility, so this is going to be closer to 0. So this is going to drag you down by 1. This is going to drag you down not as much. But then in addition to that, if you want the agent to work, and you can imagine that in some situations you might want the agent to work, and other times you might not care what he does. I'll give you an example of that in a minute. You've got to make sure that this equation is satisfied. So, you know, the alpha, remember, is bigger, so that's going to be a bit of an issue. So you got to compensate him for that. But in addition to that, you've got to make sure that he would rather work than shirk. And so you've got to screw around with this WX thing inside so that this inequality is satisfied, even though it's true that if you had a constant W here, well, the inequality would go the other way. Okay. Fairly straightforward to solve this problem, at least numerically. You take a first order condition, it's a Kuhn-Tucker problem. Okay. So when you do that, there are 2 Lagrange multipliers. You notice if you wanted the guy to work, you've got to satisfy both incentive compatibility and participation. 2 Lagrange multipliers. One of them drops out nice and easily. You're left with one of the others. That is this one. Don't give the ratio of the 2. And then you have this weight contract being equal to this. So basically, if you're only interested in getting the agent to look after your house on the Dalmatian coast in winter, you could probably pay them a shirking contract. In other words, they really don't have to do very much because no one's going to be in it anyway. Just make sure the shutters are down, stuff like that. If you want them to work hard during the summer, on the other hand, by getting people in and making the places clean and responding to all the other stuff, you've got this Airbnb out there. I really don't. So then, just thinking about it, then you would have to pay a kind of a contract that would pay them something that reflects the revenue that you get. And so you pay them what I'm going to call a certainty equivalent, okay, to work. It's going in, and that certainty equivalent has to be enough to get them enough utility. That's one thing you're going to do, all right? And the other thing is you're going to be paying them this positive risk premium which twists the contract around so that this participation constraint matches up. Okay, so there are 2 aspects to this. Number one, you've got to move the utility up to get that certainty equivalent, but then you've got to move it up even further to make sure that the incentive compatibility constraint is satisfied as well. So we can think about, within this very simple model, what are the main kind of social welfare kind of issues that are resolved here? Okay. Well, first of all, we can talk about the cost of the moral hazard. And the cost of the moral hazard is how much would you be willing to pay for a perfect monitor? Okay. In other words, a little piece of camera or something that watches the person who is supposed to look after your house, making sure that they're always doing everything just right. And you've also got them on the internet so that you know when they're communicating, you're seeing what's going on. You don't have to do it retrospectively after all. You don't have to do it in real time. So you've got this perfect monitor. And in that way, that perfect monitor is going to is going to do exactly what you want it to. You can pay them a fixed wage in that case because they will know that they're being monitored, all right? And so that is just going to be the difference between, well, what's the wage that you paid, or how much you're willing to pay for that? Well, that's just the difference between the expected wage you have to pay them now, minus what you would have to pay if there was a perfect monitor. Okay, and we know what the perfect monitor is, at least if we knew what the risk parameter and the work disutility parameter is, and that just then is this expression that's coming straight from the wage contract itself. Then, so that's one measure, the cost of moral hazard itself. Okay. Second would be, well, what is the non-pecuniary benefit that the manager would get out of shirking? Okay, how much would a Greenpeace person get from being CEO of BP? You get away with it. Okay, pull down all those oil wells. This is the monetized loss from working versus shirking. So this is the monetized amount you get from shirking. This is the monetized amount you get from working. So you get this difference here. The reason I'm giving you these kind of parameters, of course, is not because you like looking at Greek letters, but because we're going to put numbers on these in a minute that come from what people do and what managers do. And then there's the issue is what would be the gross loss a firm would incur if the manager was allowed to shirk versus work. Suppose you couldn't monetize the guy, what would happen then? And how would that work? Well, why is that relevant? Suppose we put a cap on CEO compensation, for example. What kind of implications might we expect? Moving now to the identification aspects. We've got a probability density for what happens when the person works or not. Now, how do we know when he's working? Well, we can look at the contract. If he's being paid a fixed wage, well, he must be shirking. And the reason why he's shirking is because the shareholders are comfortable with that. So the Airbnb owner is comfortable with a person shirking because that's all they want them to do. And it's only in the summer that you care about them working. Now, if you go to the managerial contracts, in fact, the compensation is all over the place for reasons I'll get to in a little bit. So it's a safe assumption to assume to make that, in fact, they are incentivized all the time to work, so they get heart attacks and stuff like that. It does take a toll on your health, no issue about it. Then there's this likelihood ratio for shirking versus working. How on earth are we going to get that when they're actually incentivized to work? Well, that'll come through the contract itself, because if you go back a couple of slides to the optimal contract, you'll see the G of X appearing in there, and so that's how we're going to identify that G of X. There's this distaste for shirking relative to the outside option. Well, that's going to give you some, and the distaste for working. Those two things are going to tell you something about again from the contract. We'll have to talk about that in a minute. The panel data set, we'll imagine, consists of profits and wages, and we're going to assume that the profit is just the expected value of the wages that we see given the state variables. So we're going to do some pre-smoothing, if you like, to worry about this. And in that sense, I want to argue straight off that f of x, the probability density when the guy's working, and also the wages are identified straight off outside of the model. Okay? So really, the only thing that's left to identify in this model is that likelihood ratio, which is going to give the shirking density. I'll get you. And also the parameters for disstaged working, discase shirking, and also risk aversion parameter. Go.
Why do we need to assume that the agent is averse?
Why do we need to assume the agent is risk averse? Okay. Well, main reason is that if he was risk neutral, sell him the firm. Now suppose, and so that would achieve a first best. Now, then there's a kind of issue, follow up, I suspect, is, well, gee, maybe he has liquidity constraints. Right, I'm putting words in your mouth, I know. Suppose the agent is risk neutral, but has liquidity constraints, so you can't sell him the firm. Otherwise, you could get the first bet. So that must be the reason, okay? Well, in that situation, now you've got a liquidity constraint, so you've got to think about a contract that's optimal when the agent is risk neutral and has a liquidity constraint. Now, notice that's not going to be a trivial contract, because as he works, that liquidity constraint is going to be relaxed, right? Because he's going to get more wealth. And so it's now going to be a very interesting dynamic contract. And so that is part of what's going on in terms of the assumption here. Part of it's tractability, and part of it is, well, we're not really sure how to identify the differences between the two. All right, let's keep going. Let's keep going and roll along as if the model is actually specified correctly. Now, it turns out that you can get the first order condition straight off the Lagrangian fairly well, and it's useful to define what we'll call V of X as the kind of utility equivalent of what your wages are going to be in the first order equation. What I want to do is, in this couple of slides, point out that if you knew the risk aversion parameter, if you knew what it was, then you would be able to identify all the other parameters. And so the approach to identification in this world is to say, given the risk aversion parameter, let's concentrate everything else out. So that alpha is a function of the risk aversion parameter, beta is a function of the risk aversion, along with the moments that you get from the data, and use those to identify everything up to the risk aversion parameter, and then what we'll call the observationally equivalent set. In other words, the set of things that aren't identified or can only be partially identified can be boiled down to what are the conditions that the risk aversion parameter must satisfy. I'm going to be more explicit about that in a minute, but one of the reasons I wanted to go through this simple model is to show you how it's done. So here's the first order condition, and notice that we're going to make an assumption here that as the output goes out to infinity, the probability that the guy was shirking goes to 0. That's what this assumption means. It's saying that the density of shirking versus working goes to 0 conditional on seeing the output is really high. If you get great output, it was because the guy was working. You couldn't have done it if he shirked. That's what that limiting condition says. And so that's another identifying assumption that we're going to put on this. Well, if you do that and send this out to G of X, send G of X out to 0, take the limit, well, then you get this amount, okay? And what does this correspond to? Well, in this case, we ask, what happens to the guy's compensation when X goes out to infinity? So we look at the highest compensation that he can get as X goes, well, not necessarily the highest, but the compensation, because I'm not assuming anything about monotone ratio, likelihood ratios here. We look at what happens as X goes to infinity. And then we get an answer, an estimate of this compensation here. Conditional on, not conditional, but as what's the highest compensation? What is the compensation that we see for the highest X? All right, that's what we're looking at here. So then we've got this guy, and if we turn it around, we've got, stare real hard at this, and then do a little bit of algebra. We take this guy, and then plug in this formula. You're going to have to take my word for it, I think. then you get this expression for g of x, the likelihood ratio. In other words, that's equal to, we've got the top compensation here plugged in at the top, and then we've got minus v of x here. So, and then we've got, well, what's v of x? That just depends on the gamma along with the w of x. And then that's the expression we've got. So notice that g of x now is a function that depends on, you can see how it depends on gamma, both through, here and here, okay? As well as we've got some numbers for this guy. All right, so that's how we get g of x being identified if we knew gamma. Now you can show that in this model with the Lagrangian, that both, it's Kuhn-Tucker problem, that both the constraints bind. Okay, so even though we're minimizing the amount that we have to pay him subject to height to working, they're both satisfied with equality. So that gives us two more equations. So we've got one equation from the first order condition, two equations from here for the participation constraint, that's this one, and also for the incentive compatibility constraint for this one. And you can see again, you've just got gamma in here, you've got gamma in here, and g of x, everything's in terms of gamma. All right. So if you knew what gamma was, you'd be home free. You'd be done. So you've got these three equations of the sort that I've just described. And then you have one more thing going for you. That is that the firm decided to make this guy work rather than shirk. And so it must be the case that getting the guy to work, incentivizing him to work, is better than letting him shirk. So that's going to give you an inequality. And here's the inequality right here, because you're basically taking the output from working versus the amount you have to pay him. And then this is what you get from shirking and the amount that you have to pay him here. Plug in all those formulas and you get that. And now you've got this one more inequality. Here is the theorem. That's it. In other words, this inequality is what's called sharp and tight. There's nothing else that you can impose on the model in order to know more about the set of identified parameters, or maximal sharp is another way some people could always be said. In other words, if you can find, if your gammas satisfy these equations, if you satisfy this inequality, you pick alpha, you pick beta according to gamma, you put g according to gamma, and then you see that it satisfies this inequality, then it is observationally equivalent to the truth, given that the model was actually generated this way. Okay? So this is a highly nonlinear model where you can get full identification results straight off where you're going. All right? Oh, one more point. Suppose the model doesn't have any gammas like that. You're done. Probably include the right answer. Because you've got an empty set, well then, I'll get you. You got an empty set, then that's basically, that's rejecting the model. Yeah.
How do you prove this sharp and tightness?
How do we prove the sharp and tightness? Good. We start out with these things being set. Tightness is easy. Sharpness is the hard part. Start out with these equations that I've got here, and then we prove that if these equations are satisfied, then the Lagrangian problem has conditions that will then it corresponds to a Lagrangian problem in which you get these inequalities back where you get these first order conditions out. You know, and that's why it's hard. Because you have to go in and say, okay, suppose this is satisfied. Could this have been produced by one of those models? And then you show that these conditions are sufficient so that that is true. So there are a bunch of things that you have to establish. For example, you have to show that beta is bigger than alpha, right? Sorry, the other way around. Alpha is bigger than beta. You have to show that G is really a likelihood ratio, right? And then you have to show that given that, you got to show that set it up like that, well then you get the same set of first order conditions. So it's actually straightforward in this one. It gets harder when we start introducing hidden information, which I won't do in this lecture, but can do. Yeah.
This terminology, when you say fully identified, you don't mean point identified.
It's not point identified. It's set identified. And what I'm saying here is you know exactly what the set is. Okay.
So the model
Yes.
is objected exponential assumption.
Oh yeah, there are a million things that could be wrong. But yes.
Could you repeat the question, Father? I didn't hear the question.
So since one comment was, or maybe if the model is rejected, it's because it's a discrete or with some infinite constraint. My comment was maybe, or maybe it's the exponential.
Yeah,
For sure. For sure. And in fact, that's where I would go first. Now, the exponential utility one can be even looked at a little bit more easily than the liquidity one, because then you'd be starting to look at, well, suppose people have different risk aversion parameters for different types of positions. We've actually done that. And so, for example, we don't find any difference between women CEOs and male CEOs. Now, they're a very select group. Now, you can add some simple dynamics to this. Fairly straightforward. Suppose you got a multi-period model where you can borrow and save. And there I'm just going back to some earlier work, which I did with Sumer Alpha on complete markets. And the only market that doesn't work very well in this framework is precisely the market where there is moral hazard. Now, here's an argument that I want to pick up from Antonio, because I think he mentioned it at the end of his talk, which went along the lines of you want to focus on why the market fails, reasons why the market fails, as you sort of think about how to model it, rather than think about some kind of generalized way in which markets fail. In other words, start with Adam Smith. People do, for the most part, consummate the gains from trade unless there's a reason why they can't. And asymmetric information, of course, provides one of those reasons. So that's certainly my research agenda, as opposed to starting from the other way and saying, people can't do this, people can't do that, and then sort of asking why the government should intervene, which is all very good if you're a bureaucrat, because it gets you money. Let's move on, and I'll move out of my political framework. Let's think about the agent choosing consumption each period. Principal announces a compensation contract. Okay, then same kind of participation, effort, output is the same. And now we have this setup. Is living out to infinity, or maybe not out to infinity, maybe out to t, but the only difference that we have to worry about into t, and I need to keep in mind, is that in that case, if we wanted to have him live till cap t or something like that, we want to think about bonds that mature at certain ages, as opposed to a bond that hasn't matured out an annuity out to infinity. So that's the setup. It's almost the same. All right. In that case, we'll want to define that V differently. Instead of just putting it like this, we want to define it in terms of something like the extra consumption that you would have each period if you were to get an increase in your wage. So think about how your consumption smoothing in the future, if you live more than one period. What you'd be doing is smoothing your consumption. You're asking, how much extra consumption would I have each period? So we want to define it that way. And likewise, we have to define the alphas and the betas that way, because again, when you get a jolt in your utility that's non-pecuniary, you'll spread that too, since it has a monetary equivalent. I said that the alphas and the betas have monetary equivalents. If they have monetary equivalents, well, then you can adjust your other stuff. And so that's why you would want to adjust that. Now, for now, I'm of course just that's an ex post explanation of what we do mathematically in order to make this go. Again, you've got the same kind of problem. Now I've just put it in terms of the V's instead. The only thing that I would like to point out here is that that bond price, which changes over the periods, is going to provide a different kind of constraint about how the consumption is smoothing. And because the bond, the trade-off between the current consumption and the future consumption shifts, you're able to exploit that a little bit in being able to get more identification than the partial set that I was describing before. It's a little bit vague, but good enough for now. So basically, they're almost the same problem. Turns out that the dynamic contract in this can be decentralized to a sequence of short-term contracts. The reason is that there's no information about shirking that you get about this guy. Arrives after T+1. So why bother postponing rewards or penalties? There's no point. You might as well punish him now. Now, if you had non-expected utility, okay, you had something else apart from exponential utility. Thank you. Then in that case, there would be a potentially additional reason for thinking about things, because you want to be able to act like his bank and control his consumption as well. Here, it doesn't help you much at all. And so that's a sense in which I can imagine some of these CEOs are monitored quite closely, both on working hours and off working hours. And to the extent that they are, well, there is an issue, you know, they play golf together and all the rest of it. To the extent that they are, there might be an argument there that some sort of information that suggests that they don't have exponential utility. We'll leave that for now. Point is that this decentralized one period contract is as good as you can get in this world, even though it's a dynamic model. Oh yeah, go ahead.
So in the dynamic model, is that obvious that it's optimal to incentivize them to work overtime in every period?
Okay, when you're not incentivizing them, the contract is still the same one as before. So you incentivize them when you want them to work, summer, and then you don't incentivize them, you pay them a fixed wage winter. And what this contract says, the optimal contract is to use this contract in summer and a fixed wage contract in winter. All right, I'm going to move on to estimating this, just to give you a little bit about numbers here. Truncated normal distribution, some notion of bankruptcy, mixture of normals here to get the G of X. I'm not going to bother about the underlying parameters too much. You can get the bankruptcy constraint straight off by looking at the X's. You've got the W's if you want. You can go through limited information, maximum likelihood. That's what we did with a fixed point in the middle. That's how we did it first. In a loop at each iteration. In other words, not using the identification strategy that I described, which is going through a maximum likelihood, correcting almost maximum likelihood. It's got some pre-estimation, correcting standard errors later. What do we get? Oh, what happened here? Can I come back, please? Because you were pushing me to the very last slide. I don't know whether that was a message or not. Scribble. It's all right. We're all part of it, right? Yeah. You're seeing the slides in that reverse order. There we go. Sorry, we're still here. Not sorry at all. Here's some early stuff. We looked at the what you would lose. This is the cost of moral hazard. Okay. This is the benefits that the executive gets. Here's the cost of the firm from shirking. Just orders of magnitude worse if the firm is allowed, if the executive is not incentivized or not. You want to put those in terms of countries. This is kind of the US versus Russia. This is quite far off in terms of how much the kinds of incentives, what that will end up doing if you don't incentivize your CEOs properly. It's all very well to talk about limiting CEO wage and all the rest of it. Wait until you see what happens. And would be my response at that point. So it's something to keep in the back of your mind. Then we ask ourselves later on, moved on a few years, how have things changed between what's true now versus what was true back in 40 years ago? Okay, so we had a look at the 1970s versus the early 2000s. And so we looked at the same industries, and then we looked at the all industries to see what would happen. And the reason we're looking at all industries is because if you look at the data for the early stuff, we only had data collected by Masson and Andel Smith on these three industries. And we're asked, well, how typical are these three industries of the whole of everything that gets traded on the stock market? Okay. And so you can see that, there are some differences here. You wouldn't want to argue that they're representative, but they're not completely out of line. And so then we went ahead and asked, well, what happens to the CEOs, see that? And the non-CEOs as well. And if we looked at the firms, we could look at what's the composition. We could see how the salaries went up. We can see the options going up. Here is the stock going up, not so much. And look at this one though. Change in wealth from options held, massive. And here we've got to think about one of the components of executive compensation is not just what they're given, but also the fact that they're holding financial securities that are specific to the firm, typically options, which really means that when the firm does well, they do great. And when the firm does badly, their wealth also goes down. Now, if they're not in the firm, it does not make sense to own options and stock that way. Okay? For sure, they will not have hidden private information because they'll be locked out of it. And so the whole point is that you are, if you like, tying the captain of this sailing ship to the mast. Okay, going back to some of those little mouse stories, I've forgotten what they were called. In any event, that is a really important part of compensation. So what would we say? 50 years of managerial compensation. Here's the result that we found. Say we took the CompuStat guys and ran firms at the same size, look at that, as managers in the old data set. Their compensation would have increased by a factor of 2.3. That is, by coincidence or whatever, the increase in national income per capita over this period. Okay? And what's going on here? Why is this? After adjusting for increase in living standards. Oh, firstly, I want to say that wages did not increase by this amount. Okay, they increased by less than 2.3 over this time period. In other words, what's going on? Well, there's a whole lot more capital, of course, now than there was then. And so these managers are getting wages or compensation that reflects both the increase in capital and the increase, or less than 2.3 increase in wages. You adjust the general increase. What's going on? Hardly any of the increased managerial comes from changes in the certainty equivalent wage. Hardly any of the increase. Okay, so the certainty equivalent wage hasn't really gone up that much. Practically all the changes have come from the risk premium itself. And why has the risk premium gone up? Well, first thing is, it's not risk preferences. It's not because people are more risk averse than they used to be. In other words, tastes have not changed. We are the same humans that we were several thousand years ago. Evolution doesn't do that much for us. Maybe now, but not before. And so, one way of thinking about this is to win or lose a gamble of $1 million. How much are you willing to pay? You got this gamble. You can win $1 million or lose $1 million. You want to say, no, I don't want to have that gamble. How much am I willing to pay? $240,000. Okay, that's what these guys are saying. My master students are more risk averse than these guys. They will not make sense. So that's what's going in. Not much changes in the FOX, right? The density function. The biggest change is the sharp increase in alpha and beta. In other words, there's increased utility from shirking than before. And why is that? Well, they're in charge of a whole lot of capital, not much later. All kinds of opportunities there that weren't there before. So that's what we think is going on. At least that's what our model's telling us. Now, in the remaining time, I will stop on. More or less. It's the same, maybe. He's saying, let's see.
Can you expand a bit on your
Yeah, sure.
last,
Yeah.
Why do you think there was an increase in the utility in shirking?
Okay. Only because we're seeing higher alphas on betas. And so I'm literally taking the model and then saying what the model said, what the way to interpret alpha on beta is the opportunities that you get from being able to do something different from what the shareholders do. And then I'm purely speculating as to why could that be? And the most obvious thing is, well, how firms changed. They've probably got a little less labor than before. At least one of these three industries is chemicals is that. But the other thing that's really happened is that there's a ton more capital. And so that's the main difference that we're picking up. And after all, that's what's being fed into the model. And so in some sense, that's what had come out of it. Okay. All right. I want to open up a more complicated, sophisticated way of thinking about things because I think this kind of framework is more relevant for, or is potentially relevant for thinking about future other kinds of stuff. So we're going to have a dynamic setting. Choices made by these managers each period. There's one principle, multiple agents. There's going to be an optimal contract. still going to be period by period. I'm working on with a co-author on long-term contract, because there is scope for long-term contracting and stuff. And the nature of the contract is going to be the principal says you do this, you do that, you do something else. And each of the agents is Nash responding, thinking, given that the other guys are behaving according to the equilibrium, should I as well? Of course, the answer is yes, but almost by definition. So thinking about best responding by the agents to a contract that the manager sets, and that's a natural way to start. Now, what does it rule out? Suppose the shareholders come to the board, to the manager and say, we want you to do this. And the agents say to themselves, yeah, sure. And then they get together afterwards and then conspire against shareholders, okay? I'm sure that happens. And I think it's pretty easy when you've got dispersed ownership, okay? Because there's enough free riding amongst the agents themselves, amongst the shareholders themselves, not to monitor the board, not to monitor the managers that closely anyway. And of course, the value of the firm is then reflects that, okay? Think of half of the American industrial firms right now. GE is a great example, where you've got nobody really controlling what's going on at the top. So the managers sort of do what they want. Okay, you go even further than that. Think about what happens when Russia and Czech Republic, a bunch of these other Eastern Europeans decided to get rid of government ownership. What happened? Well, managers rolled out the equipment. Okay, so the same kind of thing going on here, potentially. And that's not what's going on in this model. What's going on in this model is a tight ownership structure, getting the managers to do what they want. What we wanted to do was ask the question in this case, why executives in large firms pay more than in small firms? That was the issue. So that's one of the papers. We went back, got a whole bunch of background about executives. A lot of this is now available straight off Executive.com. You don't have to go to Who's Who. And I just want to point out some basic facts here. Executive exit rate from the C-suite, about 12 to 18% per year, a lot of turnover, and it's turnover out. Turnover within is about 2 to 3%. That's the average, sort of more or less between, depending on the sector you pick, that's the average. They last 13 or 14 years with firm tenure, 17 years executive experience, so they might have a little bit of experience beforehand. 80% college, 20% MBAs, total compensation, a little bit more than I get. A lot more than I get. Compensation increase. Okay. Now, whoops. Sorry. Pushing too hard. Here is the salary. Those blue things. Small, medium, and large. Here is total pay in terms of grants. Okay, so don't think of salary and bonus as anything like what executives get. Just a bad way of thinking about it. What else do I want to say? You basically got, here are your PhDs, number percentage in PhDs in these. That's relevant for you guys. MBAs. That's relevant to me and my students. And here is no college. You know, as no college, they got a lot of small firms, not so many large firms. You know, they start firms themselves and they're still small. That'll do for now. Two fundamental factors maybe playing a role here. The one is just human capital of the Mincer variety. You know, if you start, it turns out that I should have said that the age of these guys, large firms have older executives than small firms. Do that? Here's age, small firms, medium firms, large firms. And part of the reason for that is that the guys in the large firms are better educated or more educated. Okay, they have more formal education. So think about the Mincer Mincer Cross, in which you get more education, you start out at this crappy job being a TA or something. Some professor don't like it. And then you eventually grow and have huge salaries to justify that bottom part and overtake people who don't have as much education as you. That's the Mincer type thing. And the other thing is, there's working within the firms seems to enhance executive compensation. So that's another thing that's going on. But there's second factor, this moral hazard. Top executives pay significantly more of their total compensation in stocks and options. In other words, once you get below a few ranks, it's just wage. It really is. It's finance officer and a couple below certainly get paid as stock and options, but once you get too far down, and you don't have to go very far, because they're being told what to do, they're being monitored, it's easy to see. It's the manager that's making decisions that are sort of hard to see whether he's working or not. And as a result of that, you've got to give him incentives in order to push him onto your side. Okay, so similar kind of thing as before. You got consumption. Oh, can we have 10 minutes?
Little less than that.
Less than
5 minutes. 5 minutes.
5 minutes. I got 5 minutes. That's good. Consumption, jobs, choosing jobs. Okay. Job ranks and various things like that. So each period, that's the sense in which it's a dynamic Roy model. Okay. And so you're making these different choices. Each period. You got human capital. If you shirk, doesn't increase. If you work, it does increase. No, I'm not going to go through the notation. And so you've got lifetime utility that's similar to before. With the alphas and the betas, you shirk, that's what happens. Okay. And the alpha, of course, brings you more disutility than the beta. Notice it depends on your history and what kind of person you are, and also what kind of job you have. So that's what's going on there. So think of this as just a Roy model right here. You're getting compensation, you've got demographics, you're making decisions period by period, solving it optimally given the compensation contract that you're getting. Let's not worry too much about this. You've got firm production in this in the same way as we talked about profits before. So this is how that model goes. You know your age, you know your background, everything, privately choose consumption. The shareholders have beliefs about you. They don't know whether you've been working or not. Okay? So that's why they have beliefs. There's a contract, and then you just go on like that. Not worry about it too much. Now we have to define a continuation value for the executive. And the continuation for the executive value function for next period out, that's what we're talking about when we talk about continuation value, is related to, well, what are your beliefs? What do you know about yourself? And what about everybody else? What do they think about you? That's the H prime part, okay? And then depending on that, you'll decide to work or shirk, and you'll be updated appropriately. And then we solve out for the worker. Along the equilibrium path, of course, you're going to be incentivized to work, okay? They will make sure that you work, because they understand your problem just as well as you do. So in equilibrium, you work, okay? You only have to worry about what's happening off the equilibrium path, which is a pain, okay? But that's what you have to do in these kinds of worlds. And so, what are we saying here? In terms of the choices that you make, you've got non-pecuniary benefits, the idiosyncratic structure, systematic changes in your alphas as well, human capital accumulation. Go from there. We get a certainty equivalent result. What kind of compensation do you have to have in order to keep going? Usual stuff from CTPs. And that, you turn that round and you get a the compensation, okay? I realize I'm going way too quickly, but it's better to do that than nothing at all. You got the compensation, going to depend on what you're doing now. It's depending on your continuation value, and it's also depending on how much do people really want you. In other words, what's driving the demand for the firm? That's where the QJ is coming from. That is going to give you the certainty equivalent wage. And then from the certainty equivalent wage, you will get the actual wage itself. There's the incentive compatibility constraint. And the incentive compatibility constraint is such that, here's one of the pieces of intuition I wanted to get to, is that if your human capital concerns are really important, then your manager does not have to incentivize you, because that human capital stuff will drive you to work anyway, because working actually gives you extra human capital. That's why, as a PhD advisor, and I shouldn't really even have Nanook in the room, I do not have to worry about incentivizing him, because the human capital will drive him anyway, so I don't have to monitor that stuff. And he knows that I'm not monitoring. He knows that. It's like, I should be talking more, not less. So that's what's going on in this part. So we were able to divide things up into the non-pecuniary parts of the utility, the investment part of the wage, the idiosyncratic part, as well as the risk premium in solving that thing. We can identify the model, believe it or not quite, but close, by looking at the CCP equations and then showing that everything else falls into place. This is the more or less standard. It's coming, of course, from the fact that we're assuming type 1 extreme value or some other distribution on the unobservables, otherwise we wouldn't. And we're also obviously assuming the other parametric stuff that we're talking about. So it's really, these alphas and betas are identified non-parametrically, well, semi-parametrically maybe, if you like. So what do we find? Because I think I just have to use that those 5 minutes. What do we find? The risk premium is playing a huge role in explaining what's going on. And if I can jump to the last slide, I think I will. First thing is, we know that large firms employ talented executives. Didn't even have to do the analysis to do that. See that straight off. There's absolutely no support for the hypothesis that executives prefer working in small firms. Okay. The argument has been that they don't like working in large firms because they have to show up the office and they work in these crappy post-war buildings. But that's not what's going on at all. They like working with colleagues in big firms. That's what's going on. There's no firm size premium for human capital. They're willing, up here, they're willing to work for large firms for less pay actually. Because probably they can network more. There's no firm size premium for human capital. Really, they sort of net out in different firms. 80% of the firm size total differential, 80% of the gap comes from the risk premium. The signal is unambiguously poorer for larger firms. In other words, the signal about what the manager is doing is worse because he's basically or she is basically a coordinator, and it's really hard to distinguish as to whether the firm did well because of his decisions or something else. And that's why the signal's worse, and that is why you get a larger risk premium in this model. And so that's what we're arguing. And the remaining 20% comes from demand. The large firms are willing to pay a premium to meet demand because they got more to lose. And so that's where we're at now. I should stop. We should have lunch. Thank you.
Hope you love the shop size, and then we're getting about